and welcome everyone to this SAP community call. My name is Vinina Chao. I'm happy to have Haodan Yang with me. She is product manager for SAP AI Business Services and also responsible for service ticket intelligence. That's why you all joined this call to hear more updates, news about service ticket intelligence, ticket clustering. Before we get started, a few housekeeping notes. You have the chance, of course, to raise all your questions that you have. We will have enough time at the end to cover them. There is a Q&A button. Feel free to use that so that other attendees can see, can vote, and can also post questions. With that, Haodan, handing it over to you.
Thanks, Nina. Hello, everyone. Welcome to this session. So in this session, I'll be sharing with you the new feature of service ticket intelligence called ticket clustering. Let's have a look at the agenda for today. So first of all, I will give you a short intro about ticket clustering, what it is, followed by the demo. And then I will share with you some scenarios or 4 use cases with examples how you can really use ticket clustering to create value for the business processes. And then I'll share a little bit more about our beta testing program with the ticket clustering. So this will also be followed by a Q&A session at the end of it. So as mentioned earlier, if you have any questions in the middle, you can also put it in chat or the Q&A part. So let's get started. Just a little bit background. Service ticket intelligence is part of the SAP AI Business Service portfolio. So SAP AI Business Services provide the strategic machine learning capabilities that to help you automate and optimize the business processes and enrich the customer experiences. So we have so far 6 reusable services. All of them are available on the SAP Business Technology Platform versus the Cloud Platform Enterprise Agreement. So you can see here that we have 3 services that falls under the topic of business document processing. We have the business entity recognition that recognize business entities. We have the document information extraction that help to extract the valuable information from documents like PDF. And we have document classification that classified documents. We also have the data attribute recommendation that is related to the master data management and the invoice object recommendation that's related to the financial processes. So service ticket intelligence help to classify and recommend the tickets. So the focus scenario is ticket handling. We try to maximize the usage of unstructured text that sits inside the ticket content to provide insights for the ticket handling scenario. So this is an overview of the features that's available for service ticket intelligence. So I will focus on the ticket clustering, which is in the beta testing stage now. But let's look at what's already available and quite successful. So we have a ticket classification. So this is the feature that classifies the incoming tickets based on the categories, based on the priority levels, and also the sentiment and the languages of the ticket. So the first 2 categories are the customized. It really depends on the customer's ticket catalog and also how they defined the priority level of the ticket. And the sentiment and language are more of the pre-trained model where the customers can consume out of the box. And the second feature is ticket recommendation. This helps to recommend the responses of the ticket based on the the similarity of the content regarding the similar tickets that has been closed and stored in the ticketing applications in the past, or it can be to match the FAQ documents. So to recommend the FAQ documents that help to solve the tickets, and also it can be used to identify if there's any existing tickets that's already been created in the system to avoid the duplicates tickets that to be created. Now our session is to focus on the ticket clustering feature. So this is a little bit different from the first two. This is an unsupervised approach to really analyze the ticket content and to identify if there's any new trends, patterns, hotspots, or insights from the tickets. So with all these three features as available and more to come, what service ticket intelligence is trying to do is to use unstructured tests of the ticket content to facilitate and automate the processing of the service request with the capability of machine learning. So now let's talk about ticket clustering, what it is. The problem we are trying to tackle, or the insight we're trying to generate, is in this, there's a lot of tickets that has been created by the customers, and you can see that the tickets are actually one of the main channel we collect and gather customer feedback, and information are really the value in the modern age now. But if you imagine that there's hundreds and thousands of historical tickets that are sitting inside the ticketing applications, it is impossible for a human agent to really go into and read one by one and really see if there's any patterns and insights that are coming out of it. So with that, we can really leverage on the capability of machine learning to help us at least to really filter out some of the unnecessary ones and to come up with some of these clustering options. And then we can go into and look at if there's any patterns that's existing and if there's anything that we can do with that. So that's what the ticket clustering of service ticket intelligence is trying to do. So I will explain in a more visual way so you can understand better. In essence, the ticket clustering feature, there's a text clustering engine that's running behind it. So if you imagine there's 6 unstructured text documents here, and with the ticket clustering engine, we get 2 clusters out of these input of the 6 unstructured text. Of course, there's an out layer that doesn't force into any of the clusters. But with each of the cluster, we get the volume or the number of the text documents that falls under each of them with some keywords to show what are the similarity or to show some of these, the overlapping of these documents. And the coherence score means that how similar these tickets are within each of the clusters. So with this insight, you can see that it makes a lot of sense for us to really focus on the cluster A, because it has 3 unstructured text documents that falls under this cluster. It's half of the overall volume of tickets, and the coherence score is very comparatively high. So what it means is that it's very likely that there's some patterns or some insights we can generate out of this cluster. So that's what, sort of the insight that ticket clustering as a feature can provide. If we put it into a more real life case or the ticket handling case, if we, for instance, we have a history tickets for the past 6 months and we upload it to the ticket clustering and to generate some of the insights, and we get a list of the top clusters with the number of tickets, with the coherence score, and with the keywords. So with that, we can really sort of identify or provide us with different lens to see what's happening in the past 6 months with the ticket content. And if there's anything that we can do with that, and or if there's any value we can generate out of it. This might sound a little bit weak at this moment, but I will give you concrete examples in the following slides. Yeah, but before that, let me just quickly share with you a demo video. So this is how it looks like, or how you can get the clusters with interaction with our ticket clustering APIs. So you can see here, I already did the file upload. And the training is already so done with the some ticket content uploaded to the engine. So the model status is already active. So now we are in the inference request stage. So you can see this is the sort of the result that is expected. For each of the clusters, we have the keywords. And also the confidence score here is the coherence score. It shows that how similar the tickets that's inside this cluster are. So there's also a score for each of the keywords. It shows the weight of it. And also there's some details of the tickets that falls under this cluster. So these are the original like input data that we upload to the model to train. So you can see our mainly are the free unstructured text out of it. So it's quite a long list of tickets. So for this group of training data set, we get 12 clusters. And of course, we can always choose to show the top, for instance, 5, or we can change into 7. And then this will help us to filter out all these other cluster sets of low priority. And we can also choose the feature of group by to focus on some of the certain categories, because you see that actually the training data set is the same as a ticket clustering with a label of the clusters of the categories it belongs to. And we also provide with some visualization. So you can see that the size of the square of the cluster actually represents the ticket number or volume that falls under it. And these are the keywords that represents the content of each of the clusters. So this is the 7 or the 5 clusters that we've identified. This is the travel data set. So there's content like flight, great surveys, also something about complaints like worst day, something like that. So these are some of the things that may be worth looking into. This is also another way of visualization with the size of the circles and also keywords identified here. Okay, yeah, I think that's the end of the demo. So this is how it looks like in the API response. Okay. Yeah. So now with that, I want to share with you 4 potential use cases we see that ticket clustering can be used into. So there are 2 personas. The first one that we think that the ticket clustering can create value for is the Ronaldo. So Ronaldo, it represents some business owners or the topic experts for some of the L2, L3 business processes. So the first use case is to identify some of the trends and patterns in the tickets. So I will go through all of these use cases with some concrete examples so that you have a better understanding of how it creates value. But basically to identify some of the values, and then we can do some of these follow-up actions to make the maximize or to optimize the operation of the ticket handling here. So this is one example that you can see that this is a co-innovation we did with one of the customers. So there's so we upload the tickets of for the past more than 1 year. It's around 500 plus tickets to the ticket clustering engine, and you can see each of the bars here represents one of the clusters that's formed with that. And the blue bar here represents the coherence score, the similarity score, and the red line here represents the ticket count, the ticket volumes of each of the clusters. And there's also additional attributes that shows the total hours that spent for each of these clusters or the tickets inside the clusters. So the total numbers, the total hours spent there actually means, the efforts or the resources spent on each of them, which in the end represents the, the money spent there. So you can also see that for each of the clusters, there's a keywords showing here. There's a list of keywords here. And with that, if we see here, similar to like the top K, actually it makes a lot of sense to really focus the top 5 clusters. Why is that? So the top 5 clusters represents 53% of the total ticket count. So 300 out of the 565 tickets. And also with regard to the hours spent on them, it actually covers 54% of total booked hours. So if we take a closer look there, based on this data, if we have a self-service automated access rule request or password reset tools, some part of the ticket can actually, we don't really need can avoid the ticket creation for that, because the customer can just follow the instructions here. And what does it mean? So it means that it might have the following benefits, like up to 73 total tickets per year can be reduced because of the self-service that's created, and up to 249 hours per year can be saved, also because of this, self-service thing that has been created. So these are some of the one examples where, after we identify some of the patterns here that happens in the tickets, and then we can do something with that. And this is tangible like results. So all these insights can really, support what you want to propose with all these, things in place. So that is an example of the first use case. Of course, with some of these insights, it can also support or help to simplify the complex, the catalog structure, or expand the catalog structure with what's happening inside the, the ticketing system. So let's also look at the example. So we think that ticket clustering can really help to streamline the ticket catalog. And this is very common, right? We usually see, if you look at the graph here, very imbalanced distribution of the ticket volume for each of the categories. So some of the categories has very large or high volume of tickets, and some of them are actually very long tail of them has very minimum volume that's received. And how to, but what is behind it, right? So usually it also means a bit imbalanced, like allocation of resources, and also, the inefficiency of ticket handling that's as a result of this imbalanced distribution. So if we already know that this is what's happening inside the ticketing system, maybe we can, put all these historical tickets to the ticket clustering and analyze. So these are the clusters that's formed with the same historical tickets, and we can see there's a mapping with the keywords in place. For instance, the top two large categories actually can be split, or it's relevant for these 6 clusters that's formed here. So it makes a lot of sense that we can really, split these big categories into some minor ones, so that it can, be better handled with maybe some subgroups. And the same applies to, the categories, the minor categories with a little volume of tickets received. Actually, you can see that, okay, so these 12 categories actually can be merged in 3 big categories, so that, there's higher volume for each of the categories, and also there's also some similarity inside them, right? So that's why they are formed. So with that, we think that, these also provide a different lens, and also to really help the, more like on the higher management level of the service centers to look at the ticket catalog and think of how to restructure it so that it makes most sense for their business processes of ticket handling. So that is the example of the second use case. And so with the feature of ticket clustering, we also think that it will help to improve the model performance of the ticket clustering feature. So of the ticket classification feature. So ticket clustering is an unsupervised approach, whereas a ticket classification is a supervised approach, where we will get, a model accuracy over there. So the model accuracy in all these machine learning features are related to the, training data sets, the quality of training data sets. So we feel that the ticket clustering can really be used and to help to improve the quality of the training data set. So in the end, that will help to improve the model performance there. And how it can be achieved. So the first example here is that usually if we look at the confusion matrix here, right? Some of the categories, the model performance is not really good. You can see there's a lot of mislabeled tickets coming out from the model prediction. And if we like zoom in to focus on this group of tickets falls under these categories, and if we run the clusters, and you can, if we run the ticket clustering with this group of tickets, and for some of the clusters with the keywords, we can see it's very easily identify these are the bad quality data sets because of the, the keywords. Maybe there's this related to some specific spams. And these group of tickets actually add a lot of noises and confuses the model in the training process. So it makes a lot of sense to remove them. And you can see that, so after drop the bad quality data sets for training, and we can create a new model. And then the new model, the model performance, especially for these, specific categories, improved dramatically. So that is one way that ticket clustering can help to remove the noises from the training data sets and improve the model performance for the ticket classification. And the fourth example is also related to the training for the supervised model, like the ticket classification. Aside from the bad quality data sets for training, sometimes we don't really have the labeled data sets for training. So that's also one of the struggles for machine learning. So what we see here, imagine that there's a group of unlabeled tickets, and how can we really utilize the content there and then create a model for training. So we can upload these unlabeled tickets to the ticket clustering, and these are the the clusters generated out of it. And from the keywords and from the the high-level content of each of the clusters, we can see a mapping of that to the existing ticket catalog. So with that, it can really help and also give some insight to help label these unlabeled tickets and then put it in the training. So that is a way that it might help to enlarge or find more availability of the training data sets for potential supervised learning of the ticket clustering. So this is the overview of these 4 use cases that we've identified that I think it can bring value. So this is just the conclusion slide. But of course, some of them we've validated, and some of them we want to further validate with each of the customers' data set, because the tricky part or the interesting thing about the ticket clustering feature is that for each of the customers, the ticket will be very different. The content will be different. So we really want to understand more how ticket clustering can help you and really increase value. So with that, I want to introduce you to the ticket clustering beta testing program in the next few slides. So we are running this 5-week beta testing program until end of Q3, because we plan to make this feature GA in Q4. So it will start with a 2-week preparation and kickoff. It will start with a kickoff meeting where we will do a one-to-one design thinking discovery workshop to understand your end-to-end business process and where ticket clustering can potentially be utilized in the middle of the process. And then we will make sure that the legal documents are requested are well in place, and then grant you with the the access to the feature APIs, so you can play around with it. Of course, we will also help the support to explore the data availabilities, and also create channel where we can have real-time communication. And this will be followed by a weekly feedback and Q&A session, where we can you will share the feedback with us about whatever your findings are, and we can support with some of these questions raised up. And this will be followed by a wrap-up meeting. We will just have a conclusion or conclusive view about the whole testing results that's generated by this project, and also have some discussions about the follow-up and next steps. So this is the overview of this 5-week beta testing program. If you're interested in it, please let me know, and then we can discuss about the next steps for that. So with that, I think I'm finished the presentation part and come to the Q&A.
Yes, Haodan, thank you. There was actually a question regarding the beta testing,
Sure.
whether it is for customers only or partners.
Yep. So partners are also welcome. So it depends. So we have partners, we have SAP partners who participate as customers, but also we have partners who bring in some customers, their customers who's interested in the testing. So both are welcome.
Nice, thank you.
Yeah. I think there's also some other questions. So I just opened the chat or the question.
The Q&A window, yes. Do you want to read the question out loud?
Okay, so there's a question by Jagan GV. Can you please advise which language coding is used for ticket clustering? Yeah, so I think we have, of course, it's not comparable to the other features that's really like public available, but we have, I think it's limited to Latin languages. So, but if you have any specific, you know, the request for the languages to support, we can also have a look at it, because you know, the process, for instance, the ticket classification feature is that, so it's the model we choose is a language independent approach, but we need the you know, the data set to validate and then to put it on the supported list. Yeah. So
Okay.
the next question is, which data requirements are needed for this machine learning functionality? So this really depends on, you know, I think it's not about, you know, the quality. So this is different from like ticket classification, right? We have some requirements because based on our experience that the model performance works best if we have like 100 or 1,000 tickets for each of the categories. But this is that it's mainly of, you know, the clusters generated. Does it make sense to you or not? So this is not just related to the volume of the tickets, but also related to the business requirements. Like usually the business stakeholders, like which just duration that makes more sense for them, the past 1 quarter, the past half a year, or the past 1 year, so that, you know, that also sort of determines that what you are looking into, what kind of like insights you are looking into for the clusters. And I think like the co-innovation, or so far what we've done is for the past 1 year, it works well for a few hundred tickets. Of course, it could not be too less because it was too sparse. But if you have, I think a few hundred will be enough to generate some insights. But also it's also related to the business needs and requirements. I hope that answers your question, but we can also, if you have the data sets available, we can also like look into it in this beta testing program together.
Thank you, Haodan. And we still have a few minutes left. You're also all welcome to raise your hand. We can unmute you to speak up if you like. Otherwise, you can continue to ask questions. Okay, so if there's no further questions, thank you for those who raised the questions. Those were very interesting questions, very valuable for everyone else to hear from you, Haodan, on your answers, also the insights, also the demo that you shared. So thank you very much for your presentation, for your time. For further information about SAP AI Business Services, Service Ticket Intelligence, go to community.sap.com/topics. This is where you will find our community topic page for SAP AI Business Services, where you can find further use cases, customer stories, more learning material, and of course, ways to connect with other community members, what they wrote, blog posts, questions that have been raised and answered by the experts, by your peers. Yeah, with that, we're ending this call. Thank you all very much.